All right, so folks, thanks you all for joining us today. Want to make sure we have enough time to get started. As Stu talked about, yes, today we are going to talk about designing networks for warehouses. And so we're very excited to have the guests that we do today. I'll kick it off. So we have Jen, who's joining us. Jen, I'm going to let you introduce yourself, and then we'll allow JD to introduce herself.
Hi, my name is Jennifer Huber, Mobility Solutions Architect for Worldwide Technology. You can find me on Twitter, Jennifer Lucille. I've been doing Wi-Fi for a long time now. I don't want to count.
And Jen is a yoga guru, amazing
Yes.
person. If you've ever had an opportunity to be at a conference with Jen, she leads a yoga session in the mornings when we can. And Jen is phenomenal.
I have audio classes online at gentechyoga.com.
Yes. And JD, we have for those of you who don't, I don't think I've ever actually called you Jonathan or John. Like, he's just JD.
Yeah, just JD. Works great for me. I know some people wonder what it stands for, so I generally put it out there. I saw someone mention a corn singer, and I tell people we're a dime a dozen. There's so many Jonathan Davises in the world that have to be known as something else. In a previous role, I was actually one of 5 Jonathans within earshot of each other. So JD was the nickname that I picked up in my career, and I've just ran with it.
Gotcha. Awesome. Well, welcome, Jen and JD. We're really excited to have you. And so this this webinar topic actually came about. We had some folks come on the show and talk about designing networks with external antennas. And we had so many questions surrounding warehouses and a lot of things that were happening, and just warehouses in general, not necessarily just dedicated to external antennas. So what we thought we would do is invite some other folks to come on and onto the webinar and talk to us about warehousing. So Jen and JD, thank you for joining us. So specifically warehouses. Jen, why don't we start with you? What makes a warehouse environment so challenging?
Well, the primary thing that makes warehouses so challenging is that the stuff that's on the shelves in the warehouses is changing from hour to hour, day to day, week to week. And it's even possible that the shelving itself could change or be moved or added to. Awesome. Just for starters.
Yeah, well, we're going to get into a lot of that. JD, what do you think is one of the most challenging environments or things about a warehouse environment?
Well, I think really Jen hit it on the head there. It's not just it's not just the fact that stock levels are changing, but the things that are stocked may change, and some of those things may be highly absorptive to RF, and other things may be highly reflective. If you have paper, for example, it absorbs RF like a sponge. If you have 11-liter engine blocks sitting there, they're highly reflective, right? So it's not just a matter of the levels changing and where that stuff resides, but also the different characteristics of every component that goes into that warehouse.
Yeah, and I think too, Jesse pointed out on the chat that's another thing, not just the inventory levels that are in there, but you've got metal racks that are housing stuff, you've got machinery that's coming in, you've got I-beams in the ceiling, the construction of it, there's a lot of concrete, there's just a lot of metal in general in warehouses. That creates a challenge versus something like an enterprise building where you've got carpet space or tile or desks. I mean, it's just a very different type of environment. So we've got all of that. So specifically talking about, Jen, some of the layout. So talk to us about what you typically see in a warehouse from a layout perspective. We know narrow aisles, but what do we typically see for networking that the things you need to look out for?
The things that you need to look out for are length of cable runs, first of all, because you may need to get Wi-Fi to a place where there's not an IDF. So you may find yourself having to put a rack up on a wall so that you can put a switch to extend the length of cabling. But you also find issues where there's layers within layers. So there's like the floor to ceiling, maybe 35, 40 feet, but you may have a 2-story of the metal mesh to create a second story for extra storage. And it's sometimes tricky to get RF in that area just because of all of the metal interfering.
And JD, what about you? What addition to what Jen's talking about, what else do you see that things that you need to look out for?
Well, one of the major things, actually, I'm going to go with two, because there's two that really I think impact a lot of people, and often they don't realize it. Roaming in a warehouse is often very high speed, especially when you start looking at operators on forklifts or tow motors, whatever you would like to call those. They move very quickly, and especially when they're, say, turning corners and shooting down aisles at high speed, those roams are really difficult. And there's a lot of thought and process that has to go into ensuring that once that forklift has made that turn, that there's an access point there for it to roam to, but it's the right access point for that area, right? So if you make that turn and you've got 7 possible roam candidates to go to, it's really easy for that device to potentially roam to to an access point that is immediately no longer available. So that's probably the one of the hardest things. And the other aspect is warehouses, like almost no other facility, have to be designed 3D, right? So if you think about our traditional design, you're looking at that top-down view, and basically the design is built for, I believe with Ekahau, it's 40 inches off the floor, if I remember off the top of my head, and which is a great number for desktops, right? It's a great number for carpeted office space. But when you look at when you start looking in warehouses, there are a lot of warehouses where the operator, especially if it's very tall racking, the operator actually rides with the forks. So the operator themselves and the computer they're using, whether it's a handheld or mounted PC, may actually go up 30 or 40 feet. And so now if you're planning for RF at 40 inches off the ground, you may realize once you're up 35 feet in the air that you no longer have the RF coverage that you need. So I think those are kind of the two big ones.
Okay.
Yeah, that brings out a good one, because when you're in that owner operator, I witnessed this recently in a large distribution center where they're now placing the customized tablets right up above the driver on the actual pillar of that we'll call it forklift, right? To you, and so it's actually sitting right there, and it's encased in a huge amount of silicone or rubber dampening, right? And so you now have to think about, okay, so this device is now encapsulated in another device, and it's being constrained by 2 metal poles beside it, and it's moving fast. And like you say, JD, it's like when you come around that corner, you need to account for that angle of arrival from that client to the next AP, right? And to make sure that we can, not getting into doing location services, but having on that same thinking of that, if you're going to make sure roam, make sure you're enabled to roam to that next AP efficiently, right?
Yeah. So let's specifically talk about external antennas. I mean, we know you can use an internal integrated AP in a warehouse, but typically you do see external antennas because of the type of environment, because of the narrow aisles and how you have to get the RF to where it needs to be, where the client devices are going to be. So JD, we'll start with you. Things with external antennas. I'm just going to kind of let you talk, because JD is an antenna guru.
I don't know that I would use the term guru, but I'm passionate about it at least. I love this aspect. I love RF, and that's the reason I love Wi-Fi. So I've been in warehouses where the first attempt at Wi-Fi in that warehouse was internal antennas at the ceiling, and especially again when looking at that 30-foot ceiling as kind of a standard ceiling height to consider. You're actually putting yourself pretty far up there. That's not the way those access points are designed to operate, and you're actually putting yourself in a situation where, unless you are looking at a whole lot of that higher use in higher up in the racks, it's probably not the best solution. You're also now looking at in that situation, putting access points down the aisles and again, forcing more roams, which a lot of devices that are used in warehouses may not have the best roaming algorithms in place.
Mhm.
So ideally now, what the best thing to do really is to begin looking at actually using patch antennas to really shape that coverage and ensure that you're providing as much coverage as you can on that access point, getting your signal level up, obviously with a little bit of dB gain that's bidirectional because it's antenna based and not not coming out of an amplifier. Um, so you're getting better receive sensitivity and ensuring that you are shaping that signal in a way so that you're not really having a lot of coach channel contention. So that's going to be a big thing. So when it comes to antenna polarity, I talked about this at WLPC last year in 2019. I was working a very large warehouse and doing exactly this, right? External patch antennas, end of the aisle, shooting down these really long aisles. And I wasn't, the math wasn't adding up, right? And I was really kind of trying to figure out why I was getting less signal on the floor than I was expecting based on the location. And it was a significant amount. It was about 20 dB difference. And what through stumbling through this, and this was a little bit earlier in my career, I came to that realization and realized that what I was saying was the beacon, and on most devices, the beacon goes out the first antenna radio chain. So in this case, I was using Cisco. So it was going out that radio chain A or radio chain 1, I forget what it was back then, but I had taken a wide patch antenna that has a very wide beam width, and I had turned it 90 degrees and pointed and tilted it down so that it would shoot down the long aisle, provide that coverage down that long aisle without putting any signal into the racks, actually into the racks, so that the next aisle over there was minimal signal. Well, when I did that, right, that first, because it was a dual polarized antenna, that first radio chain that normally would be vertically polarized has now been horizontally polarized. So every time a beacon, anything that was sent out to all clients, so beacons, anything along those lines was sent, it was sent out only through that first radio chain when we couldn't do MRC or anything along those lines. And for that reason, especially to roams, it was slowing roams down because the signal wasn't as high as it should have been. By simply swapping the antenna, it was funny because when the light bulb came on, it was definitely one of those aha moments. Swap the antenna lug for that first for that first radio chain to what was now a vertically polarized antenna, and I immediately saw that dB gain jump. So it's those things like that you have to be careful of. Obviously, cable length, when we start talking about adding cable length, as long as we keeping those cables fairly short, we don't have too much to worry about. But I have been in warehouses where I've saw 100 feet of LMR 400 where you've got 50 of it coiled up, by the access point. And when you start looking at that distance and you look at the connector loss, and now you're shooting yourself in the foot, not just because of obviously your transmit power, but again, going back to that whole receive sensitivity of the access point. So there's some real issues that kind of come from that. So I always tell people, run that network cable to the absolute 100 meters if you have to. That's fine, but do not put those really long antenna cables on there. That's the best way of kind of ruining a design. And then again, I mean, kind of going back to the benefits of using external antennas is you really get to be choosy and picky about what pattern you use in what locations, whether it's a patch up at the ceiling pointing straight down in an area, maybe a small parts area where people are mostly local and things along those lines, to ensure that you're getting that signal at the floor that you would lose if it was an internal access point, or shooting down aisles and those things. So I think that's probably the biggest. Those are probably the biggest mistakes I've seen in warehouses.
So Jen, I know cable length was something important to you. What have you been able to find any creative ways to manage that, or for mounting purposes? What are some of the ways you've solved for that type of problem?
Like I briefly mentioned, I mean, I've seen additional IDFs have to be added into areas in warehouses, which could just be a simple rack mount on the wall with a switch and some PoE for the APs in order to extend RF into an area maybe where the previous design had planned for a really high gain antenna, and they decided, you know, that that wasn't ideal. I've seen warehouses that were done where the wireless designer created this situation where they were splitting antennas. Like, so they thought that they were, if they took one antenna and they put it on a splitter and they pointed it 2 different directions, that they'd be doubling their coverage, not understanding that this was back in the day where the AP would switch between the 2 antenna options and send on one and then the other. So they're basically creating themselves like a huge coverage hole intermittently. I've seen things where people would split an antenna and put one inside a freezer and one outside the freezer, again, creating additional coverage holes. But with cable length, yeah, you may have more IDFs in future than you currently have now in order to do a pervasive wireless design. Things like that will be uncovered as you start to plan for more APs and where the APs should go. Yeah.
And what about, oh, sorry, go ahead, Stu. Oh, that was Judy.
Yep, sorry, I'll jump in there. And I think Jen makes a great point on IDF placement. That's one of those things that has to be considered just like antenna or AP placement. You really have to be careful about where you put those IDFs, because you want to be able to, you want to be able to service them later, right?
Yeah.
I went into a warehouse, this was, you know, several years back, and thought I'd not really worked through the whole IDF placement thing before. And so I got in, the IDFs had been installed exactly as I'd requested. Everything was really working, actually. I had literally one access point that was causing a problem. Had to go to the switch to check the patch cable, and it took me 3 hours before I could get someone to move all of the racks that had been installed below, you know, the racks of stuff that was in storage that had been installed under that IDF. So, and that was so that I could then get the lift in to do the work I needed to do.
Yeah.
So there's also a lot of thought when you're doing these designs. A lot of thought needs to go into where those IDFs get placed to ensure that you'll always have that access. Especially, I mean, you know, if it had been something more serious, if it had been a switch that had died, you know, and suddenly we've got, you know, 35 access points, you know, that are no longer, you know, up and operating on in the environment. Obviously, I would have had a lot more. I would have had someone scrambling to help me, but that's still one of those situations where every time I had to access that, I was going to have to get someone to move racks of stuff, you know, with a forklift before I could ever actually access it. So that's an important thought there that I don't think I captured in any of my notes for this.
One interesting, yeah, just real quick, one interesting thing I saw for a solution so you could access the AP if you ever needed to swap out an AP because it died, was I had a customer who installed external antennas at the recommended mounting height or what have you, but at the base of every antenna installation is where the actual AP was, so that they ran a length of cable. And I know that you get lost with that, but all of the APs were easily accessible without having to get up on a scissor lift if anything died. So that was,
yeah, because that can be a huge time thing, trying to get a scissor lift, and it may not be available, and then you have to get the person that's certified to actually get onto that thing to go up there.
So someone asked a question, Jen, and I'm going to pose this to you. For large open warehouses, such as a production floor with high ceilings, but not high equipment or shelving, how do you combat the 2.4 channel interference with your network when you are implementing both the 2.4 and 5 gigahertz coverage?
Well, you have to turn off intermittent APs, you know, or turn your power down, turn off ones that are creating more co-channel interference than they're providing good coverage for. I would say use directional antennas at the ends of the aisles and aim the RF down to where the people are. You may end up having APs suspended from cables at the ends of aisles rather than mounted on the walls, so that you can aim the RF down through the aisles, and also have an AP installation so that if it gets hit with a forklift or what have you, that it can actually swing out of the way instead of get broken Because if it's hanging off a piece of rigid conduit and a junction box, something's going to give and it's going to break, and you're going to be with a Wi-Fi outage while you get it fixed. But I've seen really creative installations where things are hung from cables so that they can tolerate being smacked around.
Okay. And actually, I'm going to pose this question to both Jen and JD, so be ready. And just kidding. So for a freezer warehouse, would you recommend an integrated internal antenna, or would you recommend an external antenna? Why and why not?
I would recommend having some sort of access, like there's probably lighting, there's probably already an access port into the freezer. I would say use an external antenna and put the antenna on the inside of the freezer and let the AP hardware be outside the freezer.
Okay.
That's what I would say.
I absolutely agree with that. Anytime that's a possibility, that's exactly what should take place. If that's not a possibility for whatever reason, then consider some type of protected enclosure inside, and then where you're only running a network cable through.
Yeah.
I've seen plenty of other ways people have tried to work around freezers, and none of them are something that I would want to do. Right? There may be situations where I had to do it, but those two options are the only ones that I really see that I would walk away feeling good about it.
And I before we move on, because I want to make sure we get to all of our content, because these are really good questions that folks are asking. But one of the things that I would suggest specifically for warehouses too is when you are doing you have your predictive design, make sure you validate and you do a survey to ensure that your coverage pattern for your antenna is performing as it's designed.
Yeah.
I see Jen is like laughing and giggling.
Yeah.
Yes.
But that's one of the things that's really, really critical. And you have to do a physical on-site survey in that regard, in order to make sure that your deployment is or your network is going to perform as it's being deployed. And I would do that prior to deployment. I would not do it post. I would make that recommendation.
If you don't do it prior, you will do it post. Let's be honest.
Yeah, you will. Yes.
You will have an issue with
that's when you discover those problems like polarization or run issues, things along those lines. So you will do it. It's just a question of whether or not you're going to do it with someone breathing down your neck.
Right. And this is good because we're getting questions based on the photo in the slide there, and that's showing a omnidirectional in a kind of in a warehouse situation. Now, the picture doesn't show the entire warehouse, so it depends because it depends on whether you could use it in that scenario. But yes, in a warehouse, you might want to actually consider a more directional AP depending on the situation, whether down the aisle. So yeah, so some of the questions in there, yes, in the warehouses, it depends on where in the warehouse, right? Omnidirectionals may not perform well way up in the rafters, obviously, for obvious reasons. You need to get that signal down to where the clients are. So it is a each case by case to understand, and you have to be creative. Like Jen and Jonathan GD are saying, is that you have to be creative in understanding, and you're going to know how your AP is going to perform when you do that post-analysis survey, right? Because the tools will allow you to, in Pro, it allows you to visualize what the antenna is doing, right?
Yeah. And I think too, that's why it's so important to make sure you understand what is happening with the inventory levels, with seasonality, with everything else as you're doing your survey, so that, for example, like Jen was talking about earlier, it can change minute to minute, hour to hour. And so you've got to make sure that your network is consistent and the performance is going to be consistent for the client devices. So, so moving on a little bit from antennas, I know that there are other design considerations. Jen, I'm going to start with you. One of the things that you were talking about that before the webinar started is the configuration going to change? And I know JD alluded to some of that with the IDF issues that he was having to try to get access. What would you recommend for shelving arrangements that are going to change constantly?
Well, shelving arrangements that are going to change constantly may force you into using omnidirectional antennas.
Mhm.
Because if you do a really tight design with directional antennas, you're basically assuming that the shelves are never going to change their locations.
Mhm.
So if you set it up so that you're shooting down the aisles and everything's all nice and pretty, and then say, for example, like over the weekend or over a downtime, like everything's changed so the shelves are going a different way, well, now nothing is going to work
Mhm.
because you've designed for a hard, fast arrangement that has now become fluid,
Mhm.
and therefore you have lots of coverage holes or things that need to be reworked substantially. So I've seen situations like that where it's been better to be less warehousey and more omnidirectional antennas.
Mhm.
So it really depends. I mean, I don't know if there are warehouse like standard operating procedures where you can get the warehouse to say this shelving will never change
Mhm.
ever, and if it does, it's on us. It's
You're
like,
lucky. You're
I
lucky.
don't know that that's even
Yeah.
possible. You know, I
Well,
don't know that that's even possible.
well, you think
Mhm.
about some areas in large distribution centers where they would store refrigerators that are being shipped out, or dishwashers, and they stack them like 3 or 4 high, right? And
Mhm.
so they sometimes change them and to better suit, logistical purposes, right? And so, yeah, you could be pointing down an aisle and you think, yeah, no, they
Mhm.
always do it this way, and then all of a
Mhm.
sudden it changes, right? And
Yep.
Mhm.
now it's like you say, it's their moving target, and so you have to kind of be creative.
JD, what about you? What other design considerations do you think need to be taken into account when you're doing your predictive and your design?
Well, let me ask this: are we specifically talking about those warehouses that move, or just any in?
Any in general.
Okay.
So let's talk about, I mean, you can talk about both.
Okay. You know, I think Jen really hit it on the head, even though she didn't say it directly. This is definitely one of those times where we have to practice our soft skills, and we have to have conversations with those warehouse
Yep.
managers, and both beforehand and after, and say, okay, I need to understand how often this is going to change. I need to understand, is this something that's going to be set in stone for the next 3 years, or is this something that you guys may decide to turn 90 degrees and move 3 feet to the left next weekend just because?
Mhm.
And in my experience, working with a very large international manufacturer, um, after working through that process with a couple of them, what we
Mhm.
began to do is go, okay, these this 40% of the warehouse is going to be stuff that it's going to be, number one, lower. It's not going to be metal racks all the way to the ceiling, and that may move around a whole lot. That may shift a whole lot.
Mhm.
This high rack area, that's going to always be high racking, and they actually signed off and said, we understand that if we change high racking, it means you have to come back out and we have to readdress this.
Mhm.
Um, once that understanding was in place, that really helped my job a whole lot. The exact person I have in mind, in fact, maybe 3 months before, I got a phone call on a Thursday, around 4:30, and was informed that Friday morning I was driving, leaving at 3 a.m. to be somewhere at 8 a.m. to work
Mhm.
on, an absolute production stopping problem. It's the end of the world because Wi-Fi doesn't work in this area, and I get there and trying to figure out, I didn't have good documentation. It was one of the very first things I did there several months before, and um, I'm kind of looking around going, I don't understand why I did it this way. And then I started looking at the floor and realized I found metal shavings by some bolts. And I asked the guy, and just happened to ask the guy, I was like, did you guys move this? And he's like, oh yeah, 2 weekends ago. And they had literally turned everything 90 degrees and shifted it maybe 10 feet.
Mhm.
And
Nice.
and it was like, of course it doesn't work, and why am I here, and why, because I'm sleep deprived, and like, so I had to practice some of those
Fantastic.
soft skills, and spend a little time showing them kind of a before and after, and once they understood that,
Mhm.
they ended up, I probably spent 60% of my billable hours with them, because they were always making changes. But once they understood that,
Mhm.
the changes required RF changes, then, it went well. So I would say always practice soft skills there. Moving on to the other design considerations, you have to know the devices that are going to be in use, and you have to know kind of what their capabilities are. There was actually a great question earlier that goes back to my conversation regarding antenna polarization. Looking for it now. David Orr asked, that a lot of times, those devices, based on antennas, if the person's holding it this way versus holding it this way, it's now cross-polarized, right? And that's a great point. What you'll generally see in most clients, though, is you're going to see generally it's going to be a 2.2 dBi dipole if it's external. If it's internal, it may even be it's likely even less than that. One of the things I mentioned in my talk a couple of years ago was iPhones. If you actually look and go into it, they actually have a negative dB antenna. And the reason for that is because they're trying to be as close to that isotropic coverage as possible, right? So that it doesn't matter what direction you turn it, it doesn't change that signal propagation. It goes back to the old, especially in the old analog days, you had your cell phone and literally, doing this versus this mattered. You had the antenna that you pulled out and all of that mattered, right? They've kind of, the magic that some of the magic they've done there is by ensuring that that device is not as sensitive to that polarization. The other thing is when that device is transmitting and receiving data, we're talking data frames here, not management frames. That is happening with at least MRC, if not some type of MIMO, right? So with that in mind, now we can use all of the radio chains and or at least some of the radio chains, and we don't have that loss that we get on beacons where it's only a single antenna broadcasting. So that's the type of thing that you have to take in mind. You have to look at what the capabilities of those devices are, what their roam settings are, going back to beat that dead cat, what the obviously what frequencies. There's no use designing a 5 gigahertz warehouse if all of your devices are 2.4, and trust me, there are still major manufacturers out there selling 2.4 only devices for warehouses.
Barcode scanners.
Yeah, exactly.
Yeah.
Right. And then you really have to pay attention to the firmware. The differences in firmware, sometimes you'll have a firmware version where that device works perfectly, and one dot revision off and that device won't even connect to the network, or suddenly becomes very sticky and doesn't want to roam, or whatever. So there's you have to really pay attention to that stuff. What else? What do you think, Jen?
I have a question.
Oh.
Actually, someone else has this question, but I'm going to pose it to Jen. What would you suggest in facilities that have really high ceilings, like 50 feet or above?
I would say in situations like that, you're going to find yourself mounting the antenna and the AP in separate places, because you don't want your antenna to be too high, because if your antenna is too high, you could potentially have coverage holes at the ground level where your devices are. This is assuming that your devices that are connecting to the Wi-Fi connect at ground level and at higher levels. So that's why you have to have like the whole comprehensive on like, what are the devices that you're using? Where are they going to be used at in the 3D space? Does an omnidirectional antenna suit your purpose? And if so, what's the footprint of that omnidirectional antenna when your AP is powered at a given power? There's so many things to consider, and you really have to have conversations with all of the stakeholders in the warehouse, the end users of the devices, so that you can get an understanding for how the wearable devices are worn, and how much blocking of the human body is going to take place. If it's a wearable on your arm or on your wrist, like, is that inside a forklift kind of thing, or is it just humans putting arms in shelves? Like, I mean, where is the device connecting? How is it connecting? There's a lot of it. It depends. There's a lot of it.
It really is.
Yeah.
The other thing, and we kind of touched on it earlier, and I think what Jen said there kind of triggered my head. Sometimes it's also a matter of asking the customer to maybe augment the client a little bit. So with forklift mounted PCs, you know, Stu brought it up earlier. A lot of times those things get mounted in a way where they're right up against some very heavy metal because they've got obviously the protective cages around forklifts. And that can create nulls in their coverage. It can create all kinds of problems. A lot of those devices also have antenna lugs. They have SMA antenna lugs or RPSMA antenna lugs. And if you can put an antenna on top of, or antennas on top of the unit, suddenly you're going to get a lot better coverage. You're going to relieve yourself of a lot of those headaches where you don't have these unknown nulls in the equipment. And especially, I mean, if you think about it, a forklift that's, you know, carrying a couple of metal racks that extend over the, you know, past whatever PC, you know, those racks are also going to create problems. So anything you can do to get that antenna a little further away from that type of stuff and give it a little bit better visibility into the network is going to be useful. And then as the second note there too is really truly understand your traffic flows. I worked, this was a warehouse that someone else designed, and I was brought in whenever there were problems shortly after deployment, where it was a whole lot of, you know, very long rows. What they had done was they had alternated. It's a fairly common design where you alternate access points, one pointing, so one pointing east-west, one pointing, you know, west-east, you know, alternating rows this way. You know, fairly common design I've seen in a lot of places. But right down the middle, if these were east-west, right down the middle, there was a north-south aisle that that got used a lot. In fact, there was a small parts area at the very southern end of that, and it was heavily used, and there was no design methodology or nothing thought about for that center aisle. So whenever a forklift hit that center aisle and turned hard, that was where the roams were, that's where the roaming issues happened, and that's where the disconnect happened every single time. So by going back in and reconsidering that design and ensuring that we had adequate coverage, and it was really interesting because especially these aisles were so long that whenever I surveyed that down that center aisle, I could literally move 6 feet. If I could see, you know, kind of down the aisle, you know, I had absolute great coverage, you know, a neg 62, neg 63, something along those lines. And if I moved 6 feet to my left, suddenly I'm neg 84. Well, that's a problem, right? I mean, that's a, you know, and especially considering, again, those forklifts turn those aisles and they keep right on moving. They don't stop for a roam. So that's kind of one of those things where you really have to understand. Again, it goes back to what Jen says. You have to talk to the users, and you have to really understand: are they working in the whole warehouse? Are they working in a small area of the warehouse? Or you know, what are the normal traffic patterns? And ensuring that whenever they get there and they make that turn, there's a very solid access point that they can connect to and hang on to for a little bit.
You know, there's a great thing on the end of the slide here is that we love our acronyms, and I know a few people out there probably are wondering, you know, what is an IDF, right? And to follow in that question is, you know, you got an IDF and cable lengths and whatnot, but most importantly, and I thought we kind of covered this here, is we often talk about LMR 400 or LMR type cabling. For most of those folks out there that are doing warehouses today, it's important. Maybe either Jen or JD could probably explain is what is the importance of making sure that, you know, the quality of that cable.
Well, there's
you know, putting on, you
rated,
got like $1,000 antenna, right? It's
well, there's like different types of LMR cabling. Some are thicker than others. There's like lots of charts online that can explain the difference. LMR 400 is the most commonly used, and there's a given dB loss per foot depending upon the thickness of the cable, the type of the cable, and when you're buying the length of cable, you're going to want to know what that is so that you can calculate what your power output from the AP is, what you're losing with your connectors, because every connector gives you some loss. If you buy your cable pre-made, the cable should come with like a given value for like, this is your cable loss for this length of whatever. But if you're making your own cables, you could be introducing more loss if your crimps are not tight. If your cable making skills are not up there, you may find that you have issues with your homegrown cabling that maybe wouldn't be such a big deal if if it weren't, you know, the cable run weren't so long. If we're talking about making pigtails, then your margin of error, you know, maybe wouldn't bite you so hard.
Because they most likely would have, you know, predetermined lengths, right?
Yeah.
It's just those oddities that you would get into.
Yeah. Folks, we're going to move on. But I do want to highlight at the end of the slide deck, we will have JD and Jen's contact information. I know there's a lot of questions that are coming in for Jen, and both Jen and JD, related to polarization and some of the other things. So we will have their contact information, so feel free. I'm volunteering their time. If you have a question, you can reach out to them, and they'll help explain or go into more detail on some of these other ideas.
Just make certain you tag Tanya every time too.
Right.
Yeah.
JD, you're off the favorite person list. I'm just kidding. All right. So specific use cases, and today for this particular one, we thought we would, instead of talking about some of the biggest successes, because I think Jen and JD have really covered all of the things that, not all of them, but most of the things you need to consider in your design to be successful. We're going to talk about some of the lessons learned and how not to do a few things, right? So take a little different twist on it. And so Jen, we'll start with you with some of the things that you have learned how to not do things.
Well, yeah, how to not do things. Be very clear when you're doing your predictive in Ekahau that you're understanding the AP mounting height versus the rack height. Like when you're designing and you're creating the modeling for the racks within Ekahau, that you have to really understand the height from the floor, the height from the ceiling, so that when you're drawing in your RF obstacles, you understand the depth of the rack, because all of that, if you screw it up even the tiniest bit, it's like exponentially problematic. So I would say that, huge. And it's huge to have gone through official training, because I have totally jacked up a warehouse design because I didn't understand that, and that's why I'm speaking to it. And I didn't understand you don't know what you don't know until you took, you know, until I took like an ECSE class, and I was like, oh yeah, I did that.
I think we've all been there.
I was gonna say, I think we've all had that moment where we're like, oh.
So folks, don't be afraid. Yeah, you know, the best of us have been there, and it's all trial and error. And a famous quote by someone is, "We learn by doing," right? And so, and that's the best thing. So,
because I guarantee, I know everyone's first design is probably not what you would consider the very best design you've ever done, right? And so we learn as we pick up tips, we have lessons learned, and we grow, right? So it's an art form, and we're able to do that.
We learn from validation surveys.
Yes, exactly.
And is the client actually working? Is it
exactly.
connecting?
JD, what about you? What's something that you want to share with us about a lesson learned?
Well, so I spoke to it a little bit earlier, but the designing for the height that the systems will be used at is important, but also surveying for the height the systems will be used at is important. One warehouse in particular, what that meant literally was me doing a floor survey, getting on a lift and going up, 25 feet and doing a secondary survey, and then going up, I want to say it was 44 feet or something along those lines was kind of the highest place that the average user would be at, and doing a third survey. And when you're looking at doing that across a warehouse that's, 650 to 700,000 square feet, which isn't even a giant warehouse, but a fairly sizable warehouse, that takes a while. Those lifts move very slow when you're extended up. There's a lot that kind of goes into that. But it also will reveal a whole lot of problems. And at the very least, what you need to do is you need to, if you know that everything was installed properly, right, and consistently across the whole warehouse, you at the very least need to survey similar sections, right? So if the whole warehouse is 300-foot long rows that go floor to ceiling, and that's all it is, then do 5 of them, and just kind of verify, and then maybe go to the other end and check some more. But more often than not, you generally have small parts areas, high racking, kit pack, things along those lines, and you kind of need to verify all of those for their specific things. One other thing I'll throw out too, that just came to mind, understand the warehouse. It kind of goes back to the flow, but it also, it's about keeping yourself alive. Work with the warehouse management to ensure that you understand everything that you should be doing for safety and can be doing for safety. Though the forklift drivers are they're used to that warehouse, right? They know it, corner to corner, edge to edge, and they're on a tight schedule. They're trying to get stuff done, which means they move very fast, and especially coming around corners. You have to be careful that you're not in the corner that they happen to be coming around. So what that might mean is, if you're working on a lift, or or maybe even just simply surveying, pushing a cart or something to survey, or walking, that maybe you're dropping cones at the end of the aisles, so that when they make that corner, they see a cone and they know something's different. There's a lot of things like that you can do besides just wearing the bright orange or bright green vest. It's also kind of useful, because I was actually in a warehouse one time where it wasn't on the row that I was on. It was one row over. Someone was putting a rack in at the very top, and I just happened to look up in time to see that they were actually, there was a third rack that they were unaware of in the middle. And when they pushed that first rack on, it actually pushed the rack that was, and it wasn't directly over my head, but it was maybe 20 feet away. It actually pushed it off the top of the rack, and it fell. And I just happened to hear it, heard squeaking that did not sound normal, and kind of looked up and saw it teetering. And I, of course, took off this, ran as quickly as I could. And and parts went everywhere. I mean, I don't think I don't think it would have sent me to the hospital, but it would not. I probably would have had to clean out my pants at the very least, right? So there's a lot that you have to take care of yourself in those environments, and sometimes that means doing exactly what the management tells you to do, and sometimes that means going a few steps further, because you are the oddity in that warehouse, and they may or may not be fully aware of where you're at and what you're doing.
And I would also speak to, it seems like it's always been my luck to draw the short straw and have the helper, the coworker that is afraid of heights, but doesn't tell me until we get to the warehouse. I don't know if you found yourself in that situation too, but it's usually me that ends up in the scissor lift, or at the top of the ladder, or the top of the whatever.
Yes. I know exactly that feeling, especially when you get up to 35 feet.
If you're afraid of heights, again, 3 points of contact, use the belt, clip yourself in, take 4 count breaths if you are afraid of heights, and don't look down. 3 points of contact, and you'll pretty much be okay.
It's funny that you're talking about holding your breath. So I was doing a tour.
4 count breaths. 4
count breath. Yeah. I was in a facility. We were looking at the infrastructure, and we were in a catwalk way high in the ceiling in a stadium, and I was having like heart palpitations, like freaking out.
Yeah.
Because, and it's like you're hundreds of feet up in the air, and I was like,
things sway, things move.
Deep breath.
Like the scissor lift, it moves and it sways, and you're like, breathe.
Yes, fun times. Well, and I think that's one of the things specifically that you have to be mindful about safety in these environments. There could be any number of things, not just the machinery and the forklifts and the things moving through, but other, there's installments where they're actually doing configs of products, building, designing, metal shavings, power torches, lots of things. So you've got to be very mindful of your environment while you're performing your surveys and while you're in the facility. But one of the other things I think too, so, just in general, what does yoga have to do with warehousing, right?
Okay.
Exercise,
I would say, yes, exactly. I would say
Yeah.
It has a lot to do with it, because when you're doing surveys like this, they're incredibly physical. You're on your feet a lot. Hamstrings get really tight. I don't know about you, but my low back does not like standing on concrete floors for many, many, many hours, which is what you're doing when you're doing a warehouse site survey. So I think that we tend to forget about needing physical activity because
Mhm.
we've just walked, you know, 1,000,000 square feet. We've gotten our steps in for the day, but it's different. I think it's much harder on your body to be standing on hard concrete floors surveying than it is to, I mean, downward facing dog, go upside down, get out of your normal, change things up. And yeah, seriously, and like do something good for your body other than I did my 10,000 steps. Yeah. So
Yeah.
it'll
Yes.
help you have a healthier, longer, happier life if you do something to be the yin to the yang, right?
Mhm. And if you're not used to it, one of the things that you can do, you know, making sure that whatever facility you're at, maybe you don't necessarily have to be the one to walk and do the survey. If the warehouse has their Ekahau license, you can have someone doing an autopilot survey for you
Yes.
in every location doing that. And so that's one of the other things to make sure that when you're doing a design and you're doing a plan, if you work for a VAR or a system integrator or something like that, making sure the location has the tools that they need to be successful in managing their network as well. And so just some tips, we've talked about some of those. Lessons learned, it's a balancing act, right? It's understanding inventory levels, it's understanding how that impacts the RF in your design. Antenna placement, obviously there's so many questions related to that, and I know folks, we did not get to all of those questions, but like I said, tag Stu on everyone, like JD said, and reach out to Jen and JD. They'll be
Absolutely.
more than happy, and or myself, to answer any questions about antennas, and then understanding traffic flow for roaming, as JD has been beating into us today. We need to make sure we understand that. But any final thoughts, Jen, JD? We'll start with Jen. Ladies first.
I would say, yeah, you're going to have to, I mean, just because you think you know what the antenna does, be very clear on your azimuth versus your elevation, understand how it's going to be mounted, be able to visualize, like just because you're looking at the two-dimensional thing, be able to turn that into a 3D with your mind so you can understand how you're shaping the RF with the antennas that you've chosen. At a height, are you adding down tilt, understanding where that RF is going to end up.
And JD, what about you? Did JD freeze on us?
I think you did.
I
But
think
you know,
JD kind of froze on us.
one thing I would like to say is footwear. Proper footwear that's comfortable, because if you're going to be doing surveying and design work, and sometimes you'll be covering 1,000,000 square feet, and that's a lot of steps, and it's on a hard concrete floor. So get yourself, invest in a really good pair of steel toe boots, especially doing warehouses. And because all warehouses are different and they require different things and different types of, maybe it's a warehouse that stores grain or potash, right? Or something that's a different thing, and they require different types of boots. So remember to get a hold of what the site safety officer has to say prior to getting on site. Yes, ahead of time. It's really part of that methodology to get in there to get that understand of what you need from a safety perspective, because having the right PPE, everybody goes home safe, right?
Yep.
And JD's back.
And he's back.
Right for the end, right?
JD,
he knows how to work it.
Tell us about when you had mentioned about the type of safety boots. You had a tip.
Yes.
Yeah.
And he froze again.
That's an important one. I think. Can you guys hear me?
Yes.
Okay, having all kinds of problems here. So yes, I would say spending a little bit more for high quality protective gear is important. I worked in a position for a manufacturer for 5 years. In the last year, they required steel toe boots or safety toe boots. And I have a large foot. In the U.S., it's a size 14. It's not easy to find boots in that size, especially safety toed boots in that size. And when I do, they're very large and very heavy. Every year a truck came, they paid for the boots. We got new boots. Yay. Generally the truck had like one pair of boots on it that fit me. And this particular time, literally the last time I got boots from them, they had a composite toe boot that was made by, I want to say Converse or someone you would not normally think of for a safety shoe. They were fantastic. Going from that steel toe to the composite toe took a lot of weight off the end of my foot. Walking in those, that it was a little more comfortable footbed. And I think I might have paid maybe $20 or $25 more than I'd paid for the other well-known, security or safety shoe companies, right? So it wasn't really that much more considering I was wearing them every day. I think that's one of those little things that will improve quality of your work life, right?
Yeah.
When Jen said earlier, you're getting your 10,000 steps in, and if you're not doing that in something that is comfortable, you're either A, not going to wear it as often as you should. That's one possibility, or B, you're just simply going to hate your life when you do. So I think there's something to be said for that.
So folks, on that note, with Wi-Fi design, you never know what you're going to get, from fashion tips to yoga and exercise tips to antennas. We bring it all together here at Ekahau, and I think that's one of the things that's very, very cool about what we do, is being able to accommodate and understand how to be flexible, how to have the right tools that you need to do what we need to do, right? And so with that, we will sign off to everyone, and thank you, Jen and JD. Fantastic.
Yes, thank you.
Tips and for coming on with us today. Absolutely wonderful. We've still had a lot of follow-up questions. We know we didn't get to them all, but like I said, here's the contact info for Jen and JD as well, to reach out if you have any questions.
Tag Connie on every one.
That's right. Yeah, and me. Yeah, I said it. I can do it. Yeah. And a lot of those questions we did actually get covered as we went answered live.
Yes.
We may have not have marked them answered, but I think
we
going
do try
through the conversations here, and especially in the chat window, I think we had a really good. And I want to give a shout out to thank you for the audience, because it looks like you guys have been very engaged in answering and helping questions, and even answering, what type of enclosures some of those were. Yes, they are a combination. They could be a Ventive, they could be an Excel text, they could be any types of those. And thanks for answering those questions in there. So this is really good, and I love the feedback. It's almost like we could do another more in depth on one of these, and actually have a camera right down in the warehouse somewhere. And so
live on site, right?
Live on site.
On location. On location. Is the
word.
Right.
Soon. Hopefully soon.
Yes.
We can do
Just
that.
make sure you have your sidekick with you.
Absolutely. I think when I look that way on my screen, I am actually looking at Tony. But I don't know how it appears on here.
I'm pointing at Stu right there.
Stu's down on my screen.
It's like the Brady Bunch, right? It's like
exactly.
All right, and folks, with that, yes, we do have some T-shirts to give away. We'll pick some random stuff, and stay tuned for social media for that. There might have been a keyword or something we said during the webinar that you have the first person to respond or something like that. So stay tuned to find out. And with that, thanks everybody.
Bye.
Thanks a lot.
Bye.